we want to work out 43% of 2,100. So this isn't a calculator paper, so we're going to have to get a bit creative in how we figure this out. So we know that 10% equals 210. So can we relatively easily work out what 1% is going to be? We're just going to divide this by 10. So it's going to be 21. So now let's try to work out 3%. Hopefully that'll be a bit easier. Now we can just times this by 3. So we'll have 21 times 3 is going to be 63. Again, you might want to write out a grid method to show how you've done that. 21, 3, 63, and add those together, 63. So now we have 10%, 1% and 3%. So what about 40%? So for that, we're just going to take the 10% and times it by 4. So that's going to give us 840. Again, you can write out a grid method or do column method if that's what you prefer. 210, 40, so, sorry, not 40, 4. So that's going to be 800, that's going to be 40, in total 840. So now we can just add up these last two rows to get our 43%. So I'm going to use column method addition. 840 plus 63, we've got 3 there, we've got 4 plus 6 is 10, so we're going to carry that 1, and then we're going to have 8 plus 1 is 9, so the answer is going to be 903. So question number 13. Katy records the number of cars using a drive-through each hour for 24 hours. Here are the results. So Katy makes this tally and frequency chart to put the data into groups. Okay, make 2 criticisms of Katy's tally and frequency chart. You do not need to complete the chart. Okay, so we're not going to look too deeply at the numbers, but some of the things we do want to have a look at are, let's just leave that, this section here. So how is she choosing to group the data? So the first group is 0 to 10. Second group 10 to 20, 20 to 30, 30 to 40, 40 to 50. So one criticism that I would make is the fact that she hasn't made it very clear which category the number 10 would fit into. So for example, in her data, she has an hour where there was exactly 10 cars. So would she add that to this group or would she add it to this group? Because they both have the number 10 involved in them. So criticism number 1, unclear groups, which category does number 10 fit into? And then criticism number 2 is probably that if you look at the data set, you can see that there's a 53 and a 57. So those 2 data points wouldn't actually fit into any of these groups because the highest grouping is 40 to 50. So my next criticism would be 2 data points do not have a group as groups only go up to 40 to 50 and data points are greater than 50. You could say 2 of the data points are greater than 50. So those would be the criticisms that I would pick up. Okay, question 14. Counters in a bag are red, white and blue, or blue. A counter is picked at random. Complete the table. Okay. So we know that the probability of getting a red is 0.15. The probability of getting a white is 0.4. So we know that all probability for any scenario should add up to 1. So 1 is equal to 0.15 plus 0.4 plus whatever the probability of blue is. I'll just write the letter B. Sorry, that should be a plus. So B is going to be equal to 1 minus 0.4 minus 0.15. So let's do this in stages. So let's do 1 minus 0.4. So we can't do 0 minus 4, so we're going to take 1 from the 1 and carry that over. So we're going to have 10 minus 4 is 6, and that's going to be where the decimal point goes, and then we're going to have 0 minus 0, which is 0. So this first bit here equals 0.6. We still have to do minus 0.15, so let's do 0.6 minus 0.15. So again, we've got 0 minus 5, we can't do that, so let's take 1 from the 6. So we've got 10 minus 5, which is going to give us 5, and then we've got 5 minus 1, which is going to give us 4. 0 minus 0 is going to give us 0. So the blue probability of receiving a blue counter is going to be 0.45. Okay, so question 15. Here's a calculation. You can use the calculation to help answer the following questions. So they've given us this calculation because they know it's not a calculated paper, so we're going to have to try to use that and be creative to help us answer the next few questions. So the first one is work out 2,604 divided by 84. So straight away, we know that this is basically just a rearrangement of this initial calculation. So the answer to that is going to be 31. Because we've essentially just divided by 84 on both sides. So part B, work out 3.1 times 8.4. So in that situation, we've divided this side, the left side, by 10 times 10, because we've divided this value by 10 and this value by 10. So that's actually a division by 100. So this side has been divided by 100, which means we're going to have to divide this side by 100 as well. So the answer to that is going to be 26.04. And work out 31 times 85. So for this one, all we're going to do is add 31 to the answer we were given originally, because that's 31 times 84. So it's kind of like if you'd done your 31 times tables all the way up to 84, to get to 85 times 31, you would just add another 31. So that's going to give us 2635, which is our final answer.